Welcome to tonight's video as we now talk about what a series is. We've talked about sequences and explicit and recursive definitions. Now a series is an expression for the sum of the terms of a sequence. So basically now a sequence, we just list the terms. A sum, or a series, we're actually going to take and add the terms together. A couple of things before we get started. First of all, this little symbol here, it means sigma, which means to take the sum. And then the bottom will tell you the lower limit, like the first number to put in. This here is the variable that you're going to substitute in for. And then at the top is what's called the upper limit. Like that's the last number you're going to put in. So here you're going to put in from 1 all the way up to n, and then you're going to add those terms together. This here, right there, that a sub I, that tells you your rule or definition, like what are you doing, like what's the formula. So for example, there's an example there, but here we'll expand. So here the variable's I, the first number we're going to put into I is 1, the last number is 6. And so expand just means we're going to write it out. We're not going to add, we're just going to write it out. So it's 2 times 1, then we're going to substitute in 2, so 2 times 2, and then 3, 2 times 3, and then 4, 2 times 4, and then 5, all the way to 6. And that's it. That's expanding. We're done. We're not simplifying, we're not adding, we're just expanding it. For the next one, where it says expand and simplify, that's where we're going to combine like terms if we can. So we're going to start with 1. So we're going to go 5 times 1 minus 2 to the t plus 5 times 2 minus 2 to the t. Now remember, we can't substitute in for t because the only letter we're substituting for is I, plus 5 times 3 minus 2 to the t. All right, so now we're going to simplify. We've expanded. So 5 times 1 is 5, minus 2 is 3. So 3 to the t. Plus 10 minus 2 is 8, so 8 to the t. And 15 minus 2 is 13, so 13 to the t power. Now, if we could simplify, we would, but these are not like terms, so we cannot add them. So there is our sum. And so we will say, we will say like it did here, how many ever terms there are. So 5, the sum is whatever it's equal to. So here there are 3 terms. So the sum as I equals 1 of 5i minus 2 to the t is equal to, and we'll put the 3 up there, is equal to that. So the partial sum, the 30 terms, is equal to that. So here's another one where there's a variable, so we'll expand it. So in this case, we have 4 times 3 plus j plus 4 times 4 plus j plus 4 times 5 plus j. So we have 12 plus j plus 16 plus j plus 20 plus j. So when you add it up, you have 28 plus 20, 48 plus 3j when you combine like terms. So now we're going to say the sum of the 3 terms, as I starts with 3, ends with 5, of 4i plus j equals that. So that is our whole answer. And that notation matters. All right, So the next page, it wants us to write this sum, so we're going to go backwards using sigma notation. So first of all, notice we're adding 4 every time. Second of all, notice that it ... so it means it's infinite. So that means we're not taking the sum of a specific amount of terms, it's an infinite sum. So that means the upper level is infinity. We're going to start I equals 1, and now we got to come up with a rule. Well, remember, this is how we use the explicit definition. And remember, when it's adding the same thing, it's linear. So that means it's going to be 4i. And you have to ask yourself, what do you have to do to 4 to get to 2? Well, you have to subtract 2. So 4i minus 2. So there is our sigma notation. So here's another one. This one, there is no constant sum or multiplication, but it's a fraction. And notice it goes 1, 2, 3, ... 10. So that means there's going to be 10 terms if you start with 1. So we're going to find the sum of these 10 terms. Now we have to come up with a rule. Well, notice the number that you put in is always in the numerator. So the I is always in the numerator. And then notice the denominator is always I plus 1. Now the only thing to keep in mind is that it goes positive to negative. So that means you multiply by -1. And since the first one is positive, that means it has to be the 0 power. So it's n minus 1. And there you go. So now it wants you to find the sum of the 4 terms, where the rule is you take 3n plus -1 to the n. So basically it wants where you start with n equals 1. See, it says use the variable n, we'll use n. And we end with 4, because we want 4 terms. And the rule is 3n plus -1 to the n. So we expand that out. So we go 3 times 1 plus -1 to the first, plus 3 times 2 plus -1 squared, plus 3 times 3 plus -1 to the third, plus 3 times 4 plus -1 to the fourth. So that's expanded out. So then we got to simplify. So the sum of the 4 terms. So 3 minus 1. So it's going to be two plus 6 plus 1, which is 7. And then 9 minus 1, which is 8. And then 12 plus 1, which is 13. So the sum of the 4 terms is equal to 9, 17, 30. There you go. So now it says find S sub n, find the sum, where the rule is that it equals a. So basically what we're saying is that S sub n is equal to n equals 1 all the way up to n, and the rule is a. Whatever you substitute in is just going to equal this number. So that means that it's going to be a plus a plus a plus ... all the way up to a. It just depends on what n is. So it's going to equal n times a. So if this number was 10, then you would have 10 a's. If it was 9, you'd have 9 a's. So the next question says, are these equivalent? And so you have to just look, and you have to substitute in. Like, for example, if I put 3 in, 3 over 5. If I put 0 in, 3 over 5. So the first term is the same. If I put 4 in, 4 over 6. If I put 1 in, 4 over 6. So these are going to be the same if you keep that pattern. And so you got to look down the list. Same thing with this one. If I put 6 in, 6 over 5. If I put 8 in, 6 over 5. If I put 7 in, 7 over 6. If I put 9 in, 7 over 6. So it's yes. And then if I look at part C, if I look here, this is saying if I start with 0 and I go up to x, that it's equal to a sub k plus 1, meaning the next term. If I start with 1 and I go to x plus 1, that means it's equal to a sub k, which means the previous term. So, and then if you start with t and you go to x plus t, that it's going to equal x minus t plus 1. And that is a true statement. So it says to complete for number 9. So what would you need to put in there so that it was complete? So the sum as k goes to 3 of 3k minus 8 all the way up to 7. So we would have to break this up. So notice, first of all, the first term here is 9 minus 8, which is 1. So I need the first term when I put 0 in to be 1. So I would have to make it 3k plus 1. And then the last term, when I put 7 in, so 3 times 7 is 21 minus 8 is 13. So I need this last term to be 13, so I'd have to put 4 in. So same thing here. The first term has to be 1. So I'd have to start with k as negative 1. And the last term has to be 13. So I'd have to make this 3. And that would make it equivalent. The last problem here on this page, notice the sum, you subtract 5, you add 7, you subtract 9, or it goes up 9, and then 11, and then 13. Don't worry necessarily about the plus or minus, just worry about how much it goes from term to term. Because of the fact it's alternating plus or minus, you know you're going to have negative 1 to a power. Okay, so we'll talk about how that affects it. But that means you're going to have negative 1 to a power. But because it goes up 5, 7, 9, 11, 13, that also means that the rule is going to be a quadratic. So that means, since the first term is 3, right, that it's a plus b plus c equals 3. Since the second term is 8, don't worry about the negative signs. We'll take care of the negative and positive by the multiplying by negative 1. So it's 4a plus 2b plus c equals 8. And then 9a plus 3b plus c equals 15. All right, so you're going to do your matrices, and at this point, you know the A matrix stays the same, 1, 1, 1, 4, 2, 1, 9, 3, 1. The X matrix, remember, is the A, B, C. So then the B matrix is your terms, which are 3, 8, and 15. So remember, AX equals B, so X is equal to A inverse B. And you do that on your calculator. I'm not going to type it in this time. And you get x equals 1, 2, 0. So that means your rule for this is that it's n squared plus 2n. So when you do the sigma notation, so the sum, and notice how many terms you have. You have 1, 2, 3, 4, 5, 6. So the sum of the 6 terms, starting with, we'll use n this time instead of I. So n equals 1, going up to 6, So our rule is that you have n squared plus 2n, but then you also have to multiply that by -1, and it's to the n minus 1 power because the first term has to be positive, and then the second term negative, and the third term positive. So that's why it has to be to the n minus 1 power, and that is your rule. All right, I hope you enjoyed our first video on series. We'll finish up the packet in the next video. Have a good evening.